Hi, this is Tom Klepper and welcome to Part C, where we're going to set up our bias T network circuitry for layout. So this lecture, this video, is essentially going to focus on not anything that has to do with simulation. It's literally going to be setting up our circuit so that we can transfer it over to HFSS 3D layout, and then run simulations on a printed circuit board, and then eventually output it to Gerber files. So one of the problems that I've found by trying to set up a nice procedure to do this is this software is not terribly friendly with its user interface in trying to do printed circuit boards. So I've come up with what I think is a pretty good strategy to do that. There's a lot of steps, so I'm going to try to go through them carefully, and hopefully they're generic enough that when you go to lay out your board, you can use the same procedure. So here we are back in our circuit that we did last time, and we have our schematic. We've already optimized it, and we can go to View, Layout, and we can kind of take a look at it. Now what we want to do is say, hey, we want to put this circuit on a printed circuit board. So let's do a couple of things. First, let's just go back to the schematic, just so here's our starting point. I am going to go over and let's see. I'm going to stumble through this video, so I apologize in advance. I have some notes over here. Okay, yeah. So actually, let me go back. Let me go back to the layout portion. Now we have, if you click on this right here, this is your stack up layers dialog. If you had imported the FR4 correctly, you should have most of this already populated. One of the things you'll notice is that the bottom layer defaults to a negative. Okay, so what it means, it's kind of a very subtle difference. Is when you look at this, I'm only looking at the top layer. I don't see any dielectric layer and I don't see a bottom layer. So since there's no bottom layer defined, it assumes that you've drawn the negative, or that in fact the entire surface is the bottom layer. So, and same thing with the dielectric. The entire surface is the dielectric layer. So when in this kind of Nexum approach, it assumes that, hey, I'm just drawing the top layer. This goes back to what I was saying about the fact that you only need the top traces. The bottom traces are the ground. They're implied to be constant throughout, so you don't need to show them. Because honestly, when you look at this, even though you're seeing these traces, these are just circuit elements in a linear circuit simulation. This is the Nexum circuit simulator. So what we're going to do is we need to create an actual circuit board for it. So here's your procedures. First you're going to do is you're going to go over here. You're going to go back to this circuit layout, the stack up layout. I'm going to uncheck this negative. So now what I'm telling is, hey, I'm actually going to draw not just the copper and the FR4, but the bottom layer as well, top FR4 and bottom layer. You can have this pattern, and if yours doesn't show here, click on any one of these guys, right? Just to click, right click, and you'll get a list of options that you can adjust per layer. And one of them is this pattern. You can check it on if you wanted to adjust that. I do, and I use this as my copper pattern. Also, if you go to, so these should already be defined for you. And if you click on non-stack up layers, if you had downloaded that personallib.zip file and unzipped it, right, starting today, 3/16 or later, then these will already be there. If you didn't, if you did it before then you are going to need to add these two layers, solder mask top and bottom. And it's very simple to do. You would just click on silkscreen or anything, and you'd say insert below. You would give it a name, solder mask top or bottom, make sure it says solder mask, and just say OK. That's how you add layers. And these are what are called non-stackable layers. They're just extra layers. So when we go to make our printed circuit board, you're going to have the stackable layers, which is you're going to have a top, an FR4, and a bottom. And you're going to have the non-stackable layers. These are the key ones. You're going to have an outline that defines the printed circuit board shop where they're going to actually route the outline of the printed circuit board. You're going to have a silkscreen top, and then the solder mask top and bottom. Now you notice I made them purple because we're going through OshPark, and OshPark's solder mask is purple. Not necessarily. All right, so this should already be set up for you. If not, make it look like this. So you have the outline, silkscreen, solder mask, top and bottom. The other ones we don't use, so don't worry about them. They come up for default. And then you have these. So as long as everything looks like this, great. So that's the first step, is making sure that your all the layers and your layer stack up looks like this. Um, Second thing we're going to do is you're going to go over here. You're still in the layout view. You're going to go over here to the layout settings, and we're going to set a couple of really key defaults. First, you click on display, and we're going to set the grid. The grid is going to be 100 mil major. Oops, I always do that. 100 mil major grid, 50 mil for the minor grid. And then this is the drawing extent. This is the size of the whole drawing. So we're just going to make this the leftmost minus 2 inches, the top 2 inches, the bottom 2 inches, the right 2 inches, and the left minus 2 inches. And what this is saying is we have a center point to our layout, and the extents to the layout will be plus or minus 2 inches to the left and to the right, and plus or minus 2 inches from the top to the bottom. So it's a 4-inch by 4-inch panel where the center is right in the middle. That's what this says. And this says we're using 100 mil major grid and 50 mil minor division grid. So you're setting this up like this. And over in snapping, when we go to snap to the grid, we want under targets vertex, edge center, and grid, and under source vertex and edge center. So look at these cursor indications. These are critical. So when we go to a vertex, which is the intersection of two lines, it should show up as a box. If you go to the edge center of an object, it'll show up as a little triangle. And if you're anywhere and it snaps to the grid itself, it should show up as a little diamond. And again, the grid is this 100 mil by 50 mil. So these are kind of key things you're going to set up in layout settings. We are not going to do HFSS extents yet. We'll do that later, mostly because we're not in HFSS right now. We're still in Nexum circuit. So now that we've done that, let me just save it all. Okay, so we have it all set up. What I'm going to do is I'm not going to mess with this one. So I'm going to select this, right click and say copy, go up here to bias T and say paste. So I'm making a complete exact duplicate copy of this, and we're going to make this, call this C. So this is going to be the lecture C, and this is the microstrip bias T, and I'm just going to call this pre-layout work. So what we did, so at this point in time, B and C are identical because we're going to be messing with C, and if I ever screw up something, I can just go back and create another copy of B. All right, so now let's close all the windows and start fresh. So we're going to open up C, and we have our situation here. And if we go and look at our layout, that hasn't changed. Alrighty. Okay, so the first thing we're going to do is I'm going to click on these. Now you can actually drag any element around, right? It doesn't really care. They're just individual elements. But what I want to do is I want to line them all up. If you can see this, there's a little plus sign right here. That's 0, 0. That's where we're going to reference our entire printed circuit board to that exact point. So what you're going to do is click this leftmost point. We're going to say its location is 0, 0, and it's the location of the leftmost center insert spot. Okay, and then I'm going to lock it there, lock position. So I'm locking this one to start at 0, 0. Then what you're going to do is press the control key, and M is in Mike. Control M, and what it does is it realigns all of the components to start right at that point. All right, so that's kind of our step one. Let's get it all aligned. Okay, step two is we're going to go over here and say View Layers, and we're going to say Show Dielectrics. So now we're viewing all of the layers, etc. And I want you to click on the FR4 layer and click here to draw a box. And let's just draw a box. I'm just going to draw it like this. just kind of around our circuit. And we go, okay, so this box, and I can move it too. So this box is defined, and I can even adjust it if I wanted to. It's defined by 2 points. So you go to the properties menu, it says point A, 2-point description, point A, point B. Well, what do we know about it? Well, it's about 1" by 1.2". So its Y dimension, its X dimension is about 1 inch, and this is a little bit more than 1 inch. So let's go ahead and say, all right, I'm going to try to fit this thing in 1" by 1 inch. So let's start this point being upper left, and I'm going to say we'll start that at 0, and then comma, let's say 0, 0. And we're gonna make a couple steps here, so bear with me. And it's going to be 1 by minus 1.5 inches. So that's how big the board wants to be. We're gonna start at that. So what we got to do is here's the board, but there are reference to 0, 0. We need to move this board up a bit. So what I want you to type in to begin with, I'm gonna move this out of the way, is we're going to put the board at 0, 0, right? But we're going to scoot it up a bit, and we're going to scoot it up by something called WCO. This is what we're going to call our connector offset. And we're going to make that, you're just going to type this in 225 mil. Now this won't make any sense right now, but just trust me. And then what we're going to do is say, so that defines this point. Let's go over to this guy down here. So we're going to make this thing the width of the PCB wide. So WPCB wide, comma, mass is call this minus LPCB minus WCO. So what this is this is saying start it at this leftmost point, scoot it up WCO, that's this point here, then down here we're going to make it the width of the PCB wide. Now that makes sense, but we're going to make it the length of the PCB minus this WCO. So essentially we've scooted it up. So I'm going to press return. Of course it doesn't know what WPCB is. We're going to say, hey, it's 1 inch, and the length is going to be 1.5 inches, just to start off with. Okay, great. So this is the dielectric layer. Now we're going to iterate through a couple of things, and hopefully you'll follow this. I'm just putting this up here as kind of a starting point. But we notice that this guy, these two lengths here are too long. The real widths, the widths of these two traces are completely arbitrary. But this stub is hanging over the end, so we can't have that. What we'd like to do is I'd like to line these two ends up to the edges and scoot this over a bit. So let's go ahead and do that. And the way we're going to do that is we're going to go back to the layout. So look at the traces. So this is the length. If you remember, this was P port 1, the length of this piece of transmission line. This is P port 2, the length of that guy, and that's the width of stub 1, that little guy there. So if we want to line up the edges with the printed circuit board, we go to View Schematic, and we go, okay, what we really want is, where is port 1? Okay, so really what we want this guy is to be the width of the PCB minus width of stub 1 over 2. And then we want this one to be the same thing. The width of the PCB minus the width of the stub over 2. And I'm just doing this from the properties. So it adjusted it up there. So let's go back to the layout. Again, we're always, every time we go back to layout, I'm going to press Control M to adjust. Now what we see here is, yes, now these are lined up to the end of the boards. That's kind of nice. Great. There's one other thing we got to do. Again, we're going to line up these first before we move all of this over. So the traces can't. So this is what this is the dielectric layer. This is what the printed circuit board shop's actually going to manufacture. You can't have the traces right up against the dielectric layer. They have to set back a little bit. All right. So there's like I call it a trace offset. So usually like a 10 mil gap where bottom and top layer have to set back from the edges of the dielectric. So let's go ahead and adjust these for that as well. So I go back to the schematic view and we're going to modify this. So let's go back to our port definitions, and we might, do we have any more? If I go to design properties, I may have more space to do it here. Okay, so we're going to do this, and let's go back to here. Again, I apologize, this video is going to be very clunky. So what we want to do is this first one, let's not start it at 0, 0. Let's actually start it at this offset. So I uncheck the block, and then we're going to say, hey, don't start at 0, 0. Start it at W trace offset kind of 0. So what we're going to do is we're going to start that left thing over here, and again, we're going to make this trace offset just 10 mil. It could be 10 mil, 20 mil, doesn't matter. Okay, so I just scooted that over, and then we have to adjust that part there, because if I hit Control M, oh, look, see what I did? I didn't do that right. So we want to try. We want W trace offset, comma 0. Then we're going to lock it. Don't forget to lock it. Now we hit Control M, and it adjusts everything over. But now this guy is hanging over by twice the trace offset. I have to move it a trace offset to get here and move it back to another one. So we go back to the schematic view, and again, yes, this is an absolute pain in the butt, but unfortunately this is the software, and there's, after talking to the tech support from ANSYS, there's no really good way to do this. All right, so now we're going to go to let me go to design properties. So now I can kind of work with this a little bit. So let's go ahead and subtract off those minus 2 times W trace offset. That's that leftmost port. So apply. So now if I go to view layout and I hit Control M, now it's lined up. So this guy's lined up from here and this guy's lined up. Great. So what we need to do then is we need to scoot the center part over. We need to make this length and this length complementary so that the thing actually scoots over a little bit. What we need to do is add what I'm just calling a W offset. So we're just going to do an offset so that this thing scoots over by some amount. So we go back to our schematic view, and I'm doing this in steps just to show you the process. I'll go ahead and right click. I can either do it actually down here or up here. It doesn't matter. I think up here you just have a little bit more space. So what we're going to do is on the width of the right port, we're going to say port 1 is plus this W offset value, whatever it is, and let's make W offset 220 mils. And yes, I've already figured out that that's the best thing. But then we got to take it away from the right, from port 2 length. So we go minus W offset. And this way, they'll still keep the same width so that they fit on the printed circuit board. Now we can take a look and say, okay, let's take a look at our layout. I hit Control M, and bam. So I've moved this over so that we have plenty of room on both sides and the thing fits squarely on the printed circuit board. So now we've kind of justified things left and right. Great. Now what about here? At first this is kind of how I had the board, but then I thought, well, what if I wanted the edge of the board to be here so I could literally solder a connector here, meaning that I'll have my port 1 RF, port 2 RF, but maybe this wants to be an SMA connector that we run off to the DC power supply. So let's go ahead and bring this edge to here. So how do we do that? Well, the length of this PCB I arbitrarily picked as 1.5 inches. So what I'd want to do, and this is start at 0, 0. So what I really want the length of the printed circuit board to be is this offset, which again was WCO. This is the connector offset, right? That takes us from here to halfway through this trace. And then from there to here is half this trace width. From here to here is P stub 1. From here to here is the width of stub 2. And from here to here is P of stub 3. So if I made the length of this printed circuit board and added up all of those variables, it would snap right to the edge of this board. And that seems very clumsy, but honestly, there's no real good way to do that from a WYSIWYG graphical thing. It's better just to type it in. So let's go ahead and make, if I did this right, we're going to make LPCB. So we got the cutoff, the connector offset, plus W50 over 2 halfway through the that trace. That brings us to stub 1, plus P of stub 1, plus W of stub 2 is the width of that stub, plus P of stub 3, plus a trace offset, because you have that, remember the dielectric sticks out a little bit more. So that's a long expression. Stub 1, W stub 2, P stub 3. Okay, so we apply. And did we make it? I think we did. So this trace should be 10 mils back from the edge. Fantastic. So we've just laid out our printed circuit board so the dielectric is the right shape and it's from the right edge from the traces. Let me save this, and I'm just going to putz around with this just so you can see that it makes it really works. So let me do the W offset so I can scoot this whole thing a little bit. If I say 200 mils, I hit Control M, it scooted it over. You know, now it's a little close to the edge. I could make it, heck, I could make it 50 mil. Control M, and yeah, that's not right. So I just wanted to show you that you can do this 220 mil. All right, so this was, believe it or not, this was the toughest part. Okay, so hopefully it gets a little bit better from here. And just so you understand, oh, see these little things, these are just the ports. Just move them out of the way. They don't, in terms of laying out, they don't have any influence on us. And you'll see why I did this W connector offset in a bit. We're going to have an SMA connector here, an SMA connector here, and we're actually going to put one here as well. Okay, so that defines the dielectric layer. And again, we said the dielectric layer snapped into place because it includes this LPCB minus the connector offset. So the dielectric layer is all parameterized, and the lengths are put right in here in our definitions, in our in the variables. So next, what we're going to do is Control D. Okay, now we're going to add some of the other critical layers. For instance, the bottom. Okay, the bottom layer. So the way we do this, let's turn off some of the other layers just for right now. We're not going to do them. You check the bottom layer. This is in the layers, whatever it has the radio button is the active layer. You can look it up here too. So it says bottom. That means anything I draw now will show up on the bottom layer. So we have a bottom layer. What you're going to do is just grab another square and you're going to drag it. It doesn't matter what, because we're going to type everything in. So you just drag a square. You go down here and we go, okay, where does it want to be? Well, remember, it wants to be a trace offset in lane from each of these points from the dielectric, because this whole bottom layer is going to be a solid ground plane. So that means that the x-axis start is W trace offset, comma, the connector offset minus the trace offset. So that's there. And then the lower right hand corner should be the width of the PCB minus the W trace offset, comma, minus length of the PCB minus the connector offset, because we're in the whole thing, and then minus a trace offset. And if I did it right, it should snap in. Great. Now we can see it. So here is the bottom layer in green. So you can see the dielectric layer sticks out by 10 mils, and the bottom metal layer is inset by 10 mils all the way around. We can add our top trace. The top trace should be coincident with the bottom, and it does. That means the top trace and the bottom ground plane are right up against each other. Great. Okay, so it gets easier from here. What are we going to do next? So we have the top layer, the bottom layer. Now we have to do, let's go ahead and do the solder mask layers. Okay, so go ahead and click on solder mask top. So we got solder mask top. We're going to just draw a, actually, let me save this. So your layer has to be visible for you to use it. Just okay, solder mask top. So it's visible, and I've selected it, and you can see it's solder mask top. Okay, draw another square, just like that, and we're going to parametrically type it in. It wants to be the same dimensions as the dielectric layer. And I'll explain, let's go ahead and put them in here, and I'll explain what that means. So we're going to go 0, comma, connector offset, and then this was going to be the width of the PCB, comma, minus length, PCB, minus connector offset. So it's the same dimensions as the dielectric. We're going to do the same thing here for the solder mask bottom. Just go ahead and draw a rectangle, type in the 2-point dimensions. So that's 0, comma, connector offset, and then the width of the PCB, comma, minus the length of the PCB minus the connector offset. Okay, so what is this solder mask? Let me turn this off. So the solder masks are going to be identical, and when we do our board, we don't want any solder mask. So by default, when you draw a solder mask layer, which you can see here, it will always show up at the printed circuit board shop as the negative, which means you draw solder mask where you don't want it. That's an industry standard. So I've just drawn a solid box here that will be filled with solder mask, but remember it's a negative, so there won't be any solder mask there. So we've just, for right now, removed the solder mask. Okay? So let me go ahead and get rid of those. I'm going to put my dielectric layer back on. And then the last one we're going to do is the outline layer. So let me turn it on and select outline. Now, what is the outline layer? The outline layer is the thing that you're telling the printed circuit board to actually route out the board, which means by default the outline layer should be coincident on top of the dielectric layer. So if you just drew a square and said, oh, I'm going to do the outline layer there, like that, it doesn't work. The printed circuit board shops, and I've tried this, it will not recognize a closed zero width polygon as the outline layer. You need to do a zero width non-connected. So the way you do that is you draw the line. So this is a line, and you're going to just, let's see if we can just do this. I'm just going to connect here, connect there, connect there, connect there, connect there, right click and say finish. So now I've just kind of randomly drew this line. It has a width to it. So we go to here, go to our properties. First thing you do is going to make it a zero width line. Bam. Now this is done and it defines multiple points because these are segments of lines. So we have to type in each line segment. We're going to do it parametrically. So we're going to start with the first one being 0, WCO. The next one is going to be WPCB, with CO. Next point is WPCB, minus LPCB minus WCO. This one is 0, minus LPCB minus WCO. And then we're going to end it up being at 0 where we started from WCO. So we're ending it up at the start. So what we did is we just outlined the dielectric layer, but using this non-connected lines with 4 segments. Okay. Alrighty, so we're pretty close to being at the end. I know this is insanely painful, but bear with me. So I think we have defined all of the layers. And so we're just going to go through, and I think that's going to be pretty much it for this last session. So we have our layers, they're all defined, solder mask top and bottom. We're not going to do the silk screen yet. We'll do that in the next video. These are all defined, that's great. Our layout settings, we still have our display. And ironically, we really didn't need to use snapping because we're typing everything in parametrically. And we have that even if we wanted to, but we've literally, if you think about this, we've literally defined the whole printed circuit board using variables. And trust me, that will come out very handily in the future. So I think, unless I'm missing something, I think that is it for this lecture. So we've done this. Don't forget that when you're on the layout screen, press Control M to realign everything. And I think that's it for video C. Trust me, this will make a lot easier when we go into the next video. We're going to transfer this whole thing into HFSS 3D layout. Thanks for watching.